All right, let's dive into a really core concept in modern software. So you're building an application, right? And it's not just one big program anymore. It's made up of dozens, maybe even hundreds of little microservices. So how do you get them all to talk to each other without creating this fragile, tangled mess? Well, the answer is a super powerful pattern called the message queue. And today we're going to talk about its undisputed king, Apache Kafka. Okay, so let's start with the way that seems most obvious, the way a lot of us first learn to do things, direct communication. One service just calls another service's API directly. It seems simple, it's intuitive, but it hides some really serious weaknesses that can absolutely bring your entire system to its knees.
This restaurant analogy, it's honestly perfect for explaining the core problem. So look at the left side. A direct call is like a waiter walking an order directly to the chef and then just standing there, waiting. If the chef is slammed, that waiter is completely blocked. They can't take other orders, they can't serve other tables, the whole system grinds to a halt. Now look at the right. The waiter just puts the order on that spinning wheel. That's our message queue. And boom, they are immediately free to go help someone else. The chef can just grab the next order whenever they're ready. This tiny change from a direct handoff to this intermediate buffer, that is the whole idea we're digging into.
So by putting that order wheel, that message queue, right in the middle, we completely change how our services interact with each other. And this isn't just some small little tweak. It unlocks 3 incredibly powerful advantages for building systems that can scale and that don't break. These are pretty much the foundation of every large-scale app you use today. This gives us 3 huge wins. First up, decoupling. Our waiter doesn't need to know which chef is working or if they're busy or if they've even shown up for their shift yet. They just need to know where the order wheel is. That's it. Second, asynchronous processing. Your user gets a super fast response like, yep, got your order, while all the slow, heavy work happens in the background. And third, load leveling. Think about a huge dinner rush. The order wheel can pile up with tickets, and that's okay. It acts like a buffer, which prevents the kitchen from getting totally overwhelmed. The chefs can just work through the orders at their own pace.
So if this whole idea is so useful, what tool do you actually use? Well, let's talk about the industry standard, Apache Kafka. It totally dominates this space because, really, it's more than just a simple queue. It's a full-blown streaming platform that was built from the ground up for massive scale. And to really get how it works, we need to meet the main players in the Kafka world.
First up, we've got the producer. This is any part of your application that writes messages into Kafka. So in a restaurant, the producer is the waiter placing the order. But in a real app, it could be a service that fires off a new sign-up event, or maybe an IoT sensor sending in a temperature reading. Its only job is to send the data and then get on with its life. And then on the other side, you have the consumer. This is any application that needs to do something with those messages. Our chef is the consumer, grabbing orders to cook. In a real system, a consumer might be an email service that's listening for those new sign-up events so it can send a welcome message. Or maybe it's an analytics service crunching all those temperature readings.
So where do all these messages actually live? They're stored and managed by the brokers. A broker is really just a fancy name for a Kafka server. And in any serious setup, you're never going to have just one. You'll run a whole group of them together in what's called a cluster. These are the workhorses of the system. They make sure your data is stored safely and is ready to go when a consumer needs it.
And finally, how do we keep everything organized? Producers don't just randomly shout messages into the system. They publish messages to a specific topic. You can just think of a topic as a category or a dedicated logbook for a certain kind of event. So you might have a topic for user signups, another one for order placements, and so on. It is the order wheel itself, the central place where producers write to and consumers read from. Okay, now we're getting to the real secret sauce. This is the concept that truly sets Kafka apart from simpler queues, and it's something every senior engineer absolutely has to understand. How on earth does Kafka handle millions of messages every single second? The secret isn't just having big servers. It's a really clever design trick called partitioning. So instead of having one single massive line for a topic, Kafka splits it into multiple smaller independent logs. These are called partitions. It's kind of like a supermarket opening up a bunch of checkout lanes instead of making everyone wait in one super long line. Each partition is its own little ordered queue. Now, this is really important. Messages are guaranteed to be in order within a single partition, but not necessarily across all the partitions for a topic. That's a key trade-off that allows for this incredible parallelism. So if we look at our user signups topic here, you can see it's not one single thing. It's been split into 3 parallel streams, or partitions. A producer can write to any of them, but the real magic here is that we can now have 3 different consumers reading from this topic all at the same time.
So how do you actually read from all these partitions at once? Well, that's where consumer groups come into play. You can run multiple copies of your consumer application, and you tell Kafka they're all part of the same group. Kafka then does something really smart. It automatically divvies up the partitions among all the members of that group.
So here's how that works. Let's say we have our topic with 3 partitions, and we start up a consumer group with 3 members. Kafka just acts like a manager. It goes, okay, consumer A, you take partition 0. Consumer B, you've got partition 1. And consumer C, you handle partition 2. And boom, just like that, we've tripled our processing power. The best part? If one of those consumers crashes, Kafka automatically reassigns his partition to one of the others. It's a self-healing, incredibly scalable system.
Look, speed is great, but it's totally useless if you lose data. And this is another area where Kafka really shines. A lot of older message queues would just hold messages in memory. It's fast, sure, but it's super risky. If that server crashes, poof, all your messages are gone. Kafka was designed for durability from day one. It writes every single message to disk, and not just on one machine, but on multiple machines.
This safety net works through a process called replication. For every single partition, one broker gets elected as the leader. It's the only one that handles reads and writes for that partition. But then, all of its data gets copied over to other follower brokers. So if that leader server suddenly fails, Kafka's controller just automatically promotes one of the up-to-date followers to be the new leader. This gives you amazing fault tolerance and means your data is always available.
All right, so that's the core architecture of Kafka. We've talked about topics, partitions, consumer groups, replication, a lot of theory. Now, let's connect all of this to the real world and look at where you're actually going to find Kafka powering the apps you use every day.
Oh, it's everywhere, seriously. It's the backbone for tracking every click and page view you make on major websites in real time. In e-commerce, a single order placed event can be picked up by the payment service, the inventory service, and the shipping service all at the same time. It's the standard for collecting and processing logs from thousands of servers. And it's an incredible tool for streaming changes from a database to keep things like search indexes or caches perfectly in sync.
So, if you're going to walk away remembering just a few things, let it be these 4 points. This is perfect for a system design interview or just for building better software. First, remember the why: decoupling, asynchronicity, and load leveling. Know what Kafka is for. It is the king of high-throughput, event-driven systems. Understand the how. Partitions are the magic behind its incredible scale. And maybe most importantly, adopt the mindset. Stop thinking in commands and start thinking in events.
And this all brings us to one last thought. Message queues like Kafka were a massive leap forward. They let us decouple our services so they could evolve on their own. And it really makes you wonder, what's the next big leap? What's the next level of abstraction that will make our systems even more resilient, more intelligent, and more autonomous? Something to think about. Thanks so much for tuning in.